walk through a one sample t-test. So just to kind of recap, we have 3 different types of t-tests that you can complete. The one sample t-test is used when you're comparing the mean of a sample to a population mean. So for example, let's say that I want to look at the SAT scores for my class, my school, my district, whichever one of those. And I'm going to see if it is significantly different from the national average. And so the key is that you're comparing the average of a sample to a number that represents a population. And so if you look at your research question, I have, is the average math achievement score of students significantly different from the national average of 75? So a national average means they're taking everyone in the nation and they're getting the average looking at everyone. So that's a population because I'm looking at everybody. So I'm taking my students, my district, my school, whatever group you want, and I'm taking them and comparing them to that mean of 75. So the null hypothesis is slightly different because of that. So our null hypothesis is going to be that the mean of that math achievement score of students is equal to the national average score of 75. Now it's different because typically the keyword we look for is significantly different. So you can say is equal to, because if I'm saying that my sample mean is equal to the population mean, that essentially means there's no difference between the two. And our null hypothesis is always that two things are not different. So it's just a little bit different of a way of wording it that's a little less formulaic, less templated, but better represents what's being done. The mean of the math achievement score of students is equal to, would be my null. And then if you look at the alternative, I change that and I say the mean of the math achievement score of students is significantly different. So instead of is equal to, I just simply replaced with it's significantly different from the national average. And it's really important that you have that word significantly in, because it's possible that the two scores could be different. It could be a 73 versus a 75. Those are different. What we're doing in quantitative inferential statistics is not trying to state a fact. 73 is different from 75. That's a fact. We are trying to figure out, is 73 significantly different than 75? And that significantly is what that inferential statistics test is doing, is it's putting it in the context of the score, it's looking at the distribution of everyone's scores, and it's telling us that is it significantly different or is it just maybe different, which doesn't have any implications for us. So we always start with checking our assumptions. The first assumption for the one sample t-test is that there is a continuous dependent variable. So remember, we're comparing our group, one group, to a number. So when we're talking about that group, what we're comparing has to be continuous. So in this case, the math achievement score is continuous. Any kind of test score is continuous. Reaction time, weight, age, anything that's numeric, that's not a category, satisfies that continuous. And so what I did was I gave you a little bit of a sample right up here. And then you would insert your citation, which would be your textbook. And that would be an APA and text citation. So it's really simple. You're just going to state it. Then we have random sampling. So the idea is, even if you're working in your dissertation and you are taking the scores in your district and comparing them to something, you want to sample the scores in your district. So you want to randomly pick however many, and that becomes that second assumption. So you need to put all of the scores into your spreadsheet, tell it to randomly pick, say 100 values, and then you would write it up and say that The data was collected from a random sample of students, satisfying my assumption, and again, you would cite the textbook. Just like every other inferential statistic, we have to look for outliers every single time. Especially in the one sample t-test, outliers can really influence the result of what's being done here. So it's very important that we do look at the outliers. And so to identify and address them, you're going to go to the appendix and you're going to follow the directions for the Shapiro-Wilk. So that's going to be down here. And this, running these steps in SPSS, will find both the outliers and the Shapiro-Wilk value that you need to complete your assumptions. So before you actually do the one sample t-test, you're going to do that step first. All right, then you're going to move on to the next assumption, which is going to be the normality of the dependent variable. To check that, you're going to run a Shapiro-Wilk test in SPSS. So again, the steps to doing this are in that appendix. If your p-value for the Shapiro-Wilk is greater than 0.05, that means it's not significantly different from normal, meaning that we can proceed with the test. So we say, if the p-value is greater than 0.05, this is normally distributed. If it's less than 0.05, then it deviates significantly and it violates the assumption of normal distribution. Now, it's important to realize that even if you violate an assumption, you can still move forward with this test as long as you have more than 30 participants. So you would need to adequately articulate that because I have, say, 120 sample points, that's greater than 30, so my one sample t-test can continue even though this has been violated. And that's kind of the key. And so you'll insert your image of that Shapiro-Wilk table, and you'll do your write-up by inserting your p-value in here for the Shapiro-Wilk. You'll also insert your image for the box and whisker plot here to do your sample write-up. Once you're done with this, you are moving on to actually conducting the one sample t-test within SPSS. So you're going to go to Analyze, you're going to go to Compare Means, you're going to go to the one sample t-test. You would move your math achievement scores into that test variable box. You would enter the actual population mean of 75 into the test value box, and then you would click OK to get your result. So this would be what your output looks like. In the one sample statistics table, this is really just giving you descriptive statistics, because when we do an inferential statistic test, we still have to talk about the descriptive statistics. So you would say my sample had a mean of 490.53 for the math achievement score, with a standard deviation of 94.553 and a standard error of 10.918 among 75 participants. So something to that degree. You get to kind of own it. Then you have your one sample test here. And when you're looking at this one sample test, the first thing you want to look at is you want to look at this sigma 2 tail, and you want to compare it to 0.05. So if your p-value is less than 0.05, the difference is statistically significant. If it is greater than 0.05, it is not a statistically significant difference. All right. Then you have the mean difference, which is basically just saying, hey, we subtracted the two means that you found. Here's what we have. And then we have our confidence interval, which is here and here. And remember, the confidence interval is really saying that instead of just giving a precise value and saying that like the mean is this, I'm saying that I think it's going to fall between these two numbers. And that's really what the confidence interval is it's almost kind of stepping back and not wanting to get too specific on something because that could run the risk of you being incorrect. Then we have our effective size, which is going to be found by taking that mean difference and dividing it by the standard deviation. And we have a small effect, a medium effect, or a large effect. Then you're going to move into your write-up. And so here is the template with brackets everywhere that you should input values. And so everywhere there's a bracket, you're going to replace it with what it actually is. And then in this packet, this is the write-up that matches the output I just showed you right here. So you can use that output and match up with where those numbers came from. So for instance, I have a 74, I have negative 0.867, and I can go back to my output and I can say, okay, my 74 came from right here. My negative 0.867 came from here. And so that just kind of helps you mix and match things to see how to be able to do it to get to the actual write-up. And that is a one sample t-test. So make sure that you're looking at this packet. There's another video where I actually go through and complete the steps in SPSS. And being sure to look at that is going to be a critical part of being successful. But hold on to this packet, take it step by step, write out your assumptions, put the charts in, and you're going to be perfectly fine.